Hi everyone. In the given problem statement of linked list cycle, we are given an head. The head of a linked list determine if the linked list has a cycle in it. There is a cycle in a linked list, and if there are some nodes in the list that can be reached again by continuously following the next pointer, internally pos is used to denote the index of the node that tells next pointer is connected to. Note that the pos is not passed as a parameter. Return true if there is a cycle in the linked list. Now, there are two ways of solving it. So one way would be that we store the node value, not the node means the node itself into a dictionary, and if that node is again called or when through traversing right we are able to find that node again, we can safely say it is forming a cycle. And in that case, right, the cycle got formed and we can say right it formed a cycle and we can return true. But to do that, right, our time complexity would has to be bigger than big O of n, and we'd also require some space. Now there is another way of solving it using the Floyd tortoise and hare algorithm. So now let us take this example. Let us say we have these values 3, 2, 0, and -4. And the 4 is again going back to 2. Okay, so we can have two pointers. One could be a slow pointer, another could be the fast pointer. Slow would be traversing by one unit, so is slow dot next, we can go to the next pointer at the same time. But for the first, it would be fast dot next dot next. So now, right, for the slow pointer, it is going to go from 3 to 2. But for the fast pointer, it is going to go from 3 to 0 because it is traversing 2 steps. Now, the slow it would again move from 2 to 0. But at the same time, right, the fast is going to go from 0 to back to 2. So it would come like this and it would come to the second value. Now, let's say if there was not a loop, right, it could go to null. And once it had got the null, right, it could say right there was no cycle available, so it had returned false in this case. But here, right, the instead of going to null, right, it has gone back to 2. Now on the another case, the slow point is moving from 0 to -4, so it is going to the -4 pointer, and the first right would go from 2 to 4. And now at this point, right, both the slow and the fast pointer would be the same. So because the values are same, we can easily say, right, it is forming a cycle. Now how can we say that the time complexity of this will always be big O of n? Let us take this example. Let's say there could be a list. Let us form a cyclic list. It can have multiple nodes out here. So let's say the slow point would be at here and the fast would be at, let's say, after a certain interval, right, the fast would be at this position. Now to go from fast to slow, right, it could take n units. Okay, and the slow would be traversing by 1 unit at a time. So let's say for example, let us take a value, right, it is going to take 10 units. Okay, or 10 steps. Because slow is moving at one value, right, so we can easily say, right, it would be 10 plus 1 because slow is moving, so it is increasing the gap between the fast and slow. But at the same time, right, the fast is also moving by 2 steps. It is moving by 1 step, but the fast is moving by 2 step. So it would be -2 to decrease the overall value. So if I calculate it, it's going to be 9 after one iteration. The next iteration is going to be 8, 7. It will keep on decreasing in that order. So can I write instead of 10, right? Or it would be like 10 minus 1. Or instead of 10, right, let us take the value of n. So our entire time would be n minus 1. Or I can say it would be big O of n time complexity to for the first and the slow to meet at a point, or for the first to go to the null pointer. So that is the very basic of understanding, right, how tortoise and here algorithm is going to work. So you're going to have two pointers, one would be moving at one step, other would be moving at two step. Now let us jump to the Python solution of the given problem. Now let me initialize both slow and fast. So slow comma fast would be, both will have the initial value as head. Now while our fast, while we are reaching the null, right? So normally you can write only fast, but here, right, you have to remember the fast is going two steps at a time. So not only you have to take the first pointer value, but also you have to take and fast dot next. So it is basically checking whether fast or fast dot next has it found a null value. If it found a null value, it will stop the while loop, else it is going to continue. So here, right, our fast would be fast equal to fast dot next, and slow would be slow dot next. And now if fast is equal to slow, both of them had reached to a particular pointer, indicating that a cycle has been there. So in that case, we are going to return true, else our loop or the fast, right, has got a null pointer and they both fast and slow is going to never meet, thus indicating that this entire list does not have a cycle. We're going to return false. Let me run the code. As you could see, the public test cases got passed. Let me submit it. And the time complexity would be big of n, and you're not going to use any additional memory. It is showing 22. I'm pretty sure it's going to be more higher. Let's see if I submit it back. It got 81. So it's pretty efficient, this algorithm, and is running at a linear time. So that's all for this video. See you in the next one.